Pluto, a far-off and baffling smaller planet, was once an individual member of our solar system's planetary family. However, later alarming declarations by leading astrophysicists Neil deGrasse Tyson and Michio Kaku brought Pluto back into the spotlight with a stunning disclosure. They suggest that this frosty world is on a potential crash course with Neptune. But how could this happen, and what might be the outcomes of such an enormous event? Are we witnessing an interesting cosmic phenomenon? Or is there something else to this looming infinite crash? Join us as we investigate the potential outcomes of a Pluto-Neptune collision. Pluto, a previous planet that was downgraded to a dwarf planet partly due to its curious orbit, remains a subject of interest and study in the cosmic community. According to recent predictions by leading researchers, Pluto's trajectory is perilously close to Neptune's. Leading astrophysicists Neil deGrasse Tyson and Michio Kaku are both raising the warning of a potentially dangerous crash between these two planets that could be an immense threat to Earth. But how is such an event even conceivable? Pluto's journey around the Sun is unlike any other planet in our nearby planetary system. It requires a stunning 248 years to complete a single orbit. This means that since its discovery in 1930, it hasn't even completed one full revolution. However, the interest doesn't stop there. Pluto's path is marked by its highly elliptical shape, diverging entirely from the nearly circular orbits of the major planets. What makes Pluto's orbit even more unusual is its inclination, calculated at 17 degrees to the ecliptic plane. The path Pluto follows is much steeper compared to the other planets. This inclination and eccentricity add layers of complexity to its orbital pattern. One of the most fascinating aspects of Pluto's orbit is its convergence with Neptune's. For around 20 years in each orbit, Pluto actually draws closer to the Sun than Neptune, resisting what we might expect from their positions in the solar system. This leads to the natural question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other planets. The study of Pluto's orbit began shortly after its discovery. Initially, astronomers struggled to grasp its unique path. Unlike the other planets, whose orbits lie somewhat near the ecliptic plane, Pluto's orbit stood out with its steep inclination and eccentric shape. The mystery deepened with the realization that Pluto's orbit does indeed cross Neptune's. The stability of Pluto's orbit amidst these complexities is proof of the intricacies of celestial mechanics. The three-body problem in space is about figuring out how three objects in space, like Pluto, Neptune, and the Sun, move and influence each other with their gravity. It's like trying to predict where they will go based on where they start and how they pull on one another. In Pluto's case, this problem shows how its path, Neptune's path, and the Sun's gravity all cooperate in a complicated way. Terms like asymptotic libration, scope libration, along with the VSK oscillation, are part of this puzzle. According to astrophysicists, what's keeping all planets in their orbits is a kind of libration. Regarding Pluto and Neptune, this term means that whenever Pluto crosses Neptune's orbit, its position is always at least 90 degrees away from Neptune. This spatial separation is crucial in preventing their orbits from colliding. Scope libration, on the other hand, refers to the vertical movement of a celestial body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other giant planet, it is positioned far above their orbital plane, offering an extra layer of protection from potential impacts. Another critical factor in this situation is the VSK oscillation. This is named after three researchers, VAV Apple, LV, and Chi, who studied how things move in space. It's about how three space objects, like Pluto, Neptune, and the Sun, pull on one another with their gravity. This pulling influences how they move, and in Pluto's case, VSK helps us understand why its path around the Sun is so strange. Despite the apparent chaos, this oscillation helps keep Pluto's orbit stable for an extraordinarily long time. The VSK oscillation shows that even though things in space may seem wild and random, certain patterns and rules keep everything in place. All of these parts help keep Pluto's orbit stable, ensuring it doesn't collide with Neptune or stray off course. This three-body problem helps in understanding how these orbits change due to the way space objects pull on one another. Mathematical simulations in the late 1980s revealed that despite these stable properties, Pluto's orbit is actually turbulent, with minor deviations in initial conditions leading to significant differences over millions of years. However, these unusual properties of Pluto's orbit have been found to maintain stability over incredibly long timescales, effectively keeping the chaos under control. Recent computer tests have helped us understand how the giant planets like Neptune, Jupiter, and Saturn influence Pluto's orbit around the Sun. Neptune has a special relationship with Pluto, where for every 2 orbits Pluto makes around the Sun, Neptune makes 3. This resonance helps keep Pluto's orbit stable. However, Neptune isn't the only one helping. Jupiter's gravity also plays a large part in protecting Pluto's orbit. What's more, Saturn helps overall too. These tests show that Jupiter's gravity alone is strong enough to ensure Pluto stays on a steady path for an extremely long period, possibly even billions of years. It's as if Neptune, Jupiter, and Saturn are working together to ensure Pluto can continue to move safely in space without running into trouble. These peculiarities are vital in the larger context of the universe for maintaining the order and consistency of celestial bodies' movement. Without these components, the solar system as we know it would be a place of far greater turmoil and unpredictability. Bodies like Pluto could potentially collide with others or be ejected from their stable orbits, leading to a domino effect on other celestial bodies. For Pluto, particularly with discussions about it possibly colliding with Neptune in the future, understanding its orbit is essential. This gives us a clearer picture of the solar system's dynamic nature. The case of Pluto illustrates how even the most seemingly unstable orbits can achieve a state of balance through the complex interaction of gravitational forces and orbital mechanics. It also shows the importance of constant observation and study of these phenomena to better grasp our place in the universe. Investigating the depths of space often leads us to confront the eccentric nature of celestial bodies, and Pluto's orbit is a perfect example of this unpredictability. The concept of orbital chaos, which refers to the delicate dependence of a celestial body's orbit on its initial conditions, is clearly illustrated in the case of Pluto. This means that even slight variations in the dwarf planet's position or speed can significantly change its long-term orbit. Using virtual simulations has been incredibly helpful for researchers to figure out how Pluto moves in space. These simulations use intricate math to mimic how Pluto, along with other space objects like Neptune, pull on one another. By adjusting small details in the simulations, astronomers can see how even tiny changes can make a big difference in where Pluto ends up. In the late 1980s, these simulations showed something really interesting about Pluto's orbit. Despite having mechanisms like asymptotic and scope libration to keep it stable, its orbit can still be wild and unpredictable. If you start with even a tiny difference in where Pluto is or how fast it's moving, over many years its path can end up looking very different. However, despite this chaos, Pluto's orbit remains stable for a long time, billions of years. This means Pluto's journey around the Sun has a kind of order to it, even though it seems all over the place at first. Predicting large events, especially when they involve chaotic orbits like Pluto's, presents huge challenges. The inherent unpredictability of these systems means that long-term predictions are often filled with uncertainties. While mathematical simulations provide a strong tool to understand and predict the future behavior of celestial bodies, they also highlight the limits of our predictive capabilities. These models depend heavily on the accuracy of initial conditions and the complexity of the interactions they simulate. Any slight mistake or distortion can lead to drastically different outcomes, making precise predictions a daunting task. Furthermore, the chaotic nature of celestial orbits, like Pluto's, reminds us of the ever-evolving and dynamic nature of the universe. While we have made huge strides in understanding space, the case of Pluto reminds us of how our knowledge of the universe still remains limited. Understanding the gravitational influences of the giant planets on Pluto's orbit provides valuable insights into the broader dynamics of the solar system. It shows how the presence and position of each planet can have sweeping effects, influencing the stability and trajectory of other bodies within the system. So why are prominent astrophysicists only now raising concerns about a potential crash between Pluto and Neptune, despite all these complex forces working to prevent such an event from occurring? Neil deGrasse Tyson, a renowned astrophysicist, offers a unique perspective on the mysteries of our solar system, particularly the captivating case of Pluto. Tyson, known for his role in the renaming of Pluto from a planet to a dwarf planet, offers insightful commentary on the evolving nature of celestial mechanics and the public's fascination with the unexplored reaches of space. Tyson's position on Pluto's renaming is rooted in the ever-expanding knowledge of our solar system. He sees the renaming as not a downgrade, but rather a necessary adjustment to our growing understanding of the many bodies orbiting our sun. Tyson's approach to celestial mechanics is one of continual learning and adaptation. He views the intricacies of Pluto's orbit, as well as its interactions with Neptune, through a lens that recognizes the unpredictability of space. He suggests that while Pluto's orbit is stable for now, it could undergo significant shifts in the future. This possibility serves as a reminder of how much we still have to learn about the cosmos and how our understanding of it is continually evolving. The new predictions have reignited a broader debate about the nature of our solar system, as well as the forces that govern the behavior of celestial bodies. This intersection of scientific discovery and public curiosity illustrates how our understanding of space continues to unfold, with every new revelation offering both new questions and new answers. What are your thoughts on the possibility of Pluto and Neptune colliding in the future? How do you think this might reshape our understanding of the solar system and our place in the universe? As scientists delve deeper into the intricacies of Pluto and Neptune's potential collision, they are uncovering further complexities about how gravitational interactions might influence both planets. The notion that a distant, icy world like Pluto could potentially collide with a massive gas giant like Neptune challenges our understanding of planetary dynamics. While such an event remains unlikely in the immediate future, it emphasizes the vast uncertainties inherent in long-term predictions in astronomy. One of the key factors that could influence Pluto and Neptune's orbits is the phenomenon known as orbital resonance. While the two planets are not on an immediate collision course, their resonance, where Pluto completes 2 orbits around the Sun for every 3 orbits Neptune completes, plays a crucial role in stabilizing their paths. This resonance creates a gravitational dance, keeping both planets from intersecting as they are kept in sync. Even when Pluto approaches Neptune's orbit, the timing of their movements ensures they avoid direct collision, as Neptune is always 60 degrees ahead or behind Pluto in its orbit. However, the gravitational influences from other bodies in the solar system, such as Jupiter and Saturn, also help preserve the stability of Pluto's orbit. These giant planets, with their massive gravitational fields, act like cosmic guardians, steering Pluto away from destabilizing encounters with Neptune or other objects. Jupiter, in particular, plays an important role in protecting Pluto, acting as a shield by deflecting potential perturbations that could alter its trajectory. This delicate balance between the planets is what allows Pluto to maintain its orbit in the long term. Nevertheless, the possibility that this balance could one day shift is a subject of great interest to astrophysicists. The orbits of the planets are not entirely fixed. They can shift over time due to the cumulative effects of gravitational interactions, such as those between Neptune, Pluto, and the other planets in the solar system. Over millions or even billions of years, slight gravitational nudges could potentially destabilize Pluto's orbit. This is especially relevant when considering the long-term effects of planetary migrations, which are thought to have occurred early in the history of the solar system, when the positions of the giant planets might have been radically different from where they are today. In addition to these cosmic forces, the ongoing study of other celestial phenomena, like the movement of distant asteroids, comets, and trans-Neptunian objects, adds another layer of complexity. These objects can also exert subtle influences on Pluto's orbit, especially if they pass close enough to Pluto to alter its trajectory. Over time, even small changes could accumulate, gradually shifting Pluto's path. While the likelihood of a collision remains extremely low, the long-term future of the solar system may still hold surprises. It's also important to consider the implications of such a collision, even if it were to happen far in the future. A potential impact between Neptune and Pluto could have catastrophic consequences for both bodies, given the size and composition differences. While Pluto is a small, icy world with a diameter of just about 2,377 kilometers, Neptune is a colossal gas giant with a diameter of about 49,244 kilometers. Such a collision would likely lead to the destruction of Pluto, possibly scattering its remains throughout the solar system, or it could result in the planet being captured by Neptune, where it would be assimilated into the gas giant's gravitational field. Although this scenario seems improbable, the thought of such a cosmic event sparks curiosity about the fragility and instability of the solar system. It highlights the importance of studying celestial mechanics, as our understanding of gravitational forces and orbital dynamics continues to evolve. The ongoing exploration of the outer solar system, particularly through missions like NASA's New Horizons, offers valuable data on Pluto and other distant objects. These missions help refine our models and increase our understanding of how distant bodies interact, providing more accurate predictions for the future. The future of Pluto and Neptune will ultimately depend on a myriad of factors, including the gravitational influences from other planets, the movement of smaller objects in the solar system, and the continuing evolution of their orbits. While the likelihood of a collision remains a distant and improbable event, the study of their interaction serves as a reminder of the dynamic, unpredictable nature of the universe. As scientists continue to observe and simulate these complex systems, new discoveries will undoubtedly shape our understanding of the solar system and the potential for future cosmic events.